Hello everyone, this is Amir from Audio Science Review. Today I have an unusual review for you. It's an in-wall speaker from Revel, the speaker company. The model number is W553L. You can see a picture of it in here, but it may be easier to look at it at the retailer site. This is the front of it. It's got a tweeter. It's got a little adjustment, I think, for the highs, plus or minus 1 dB. The tweeter can be positioned, which is nice. And you can see the guts of it in the back here. Nothing fancy, but, good design. It's gone into it. It comes with a pretty grill, as these things usually do, and lets you hide things, although I didn't measure it with that. The standard mounting of these rotating screws. You put the speaker in, then you screw it tight, and these little tabs, these little tabs in here will rotate and grab the side of the drywall or whatever, plywood or plaster, whatever you have on this thing. So with that, let's get back into the review. Traditionally, this kind of speaker is very difficult to measure because obviously it has no back box. And if I just put the speaker on a stand in here and try to measure it, I get diffraction artifacts from the edges over here as the sound wraps around and radiates around these corners. And also the back wave from these drivers comes forward and cancels things out. So you get a measurement that doesn't look anything like when you install this in a wall, and none of those effects happen because when it's on the wall, there's no sharp edge here anymore. Although not much, maybe there's a little bit, but nothing like when you stand alone. And the back wave doesn't travel and come forward. Fortunately, this clip-hole near-field scanner that I use, and you can barely see the stand that it's on, it's a special module, very expensive, cost 4,000 euros just for the software, about $5,000 or $6,000. And what it will do, and this is the microphone, by the way, and I've put absorbers around it to stop the reflections from the microphone stand, because this speaker, when the sound waves get, the wavelength gets small enough, they become significant relative to the dimensions of the microphone mount that's on a boom here. And they reflect back and then reflect forward and so forth, so you get a little bit of comb filtering. But fortunately, the wavelength is small, so you can put just 1 or 2 inches of padding in there, and it'll absorb it. And I borrowed quilt padding from my wife and made a makeshift one, and it's worked, and I haven't messed with it. Anyway, the way clip-hole near-field scanner works in this mode is that it will take the speaker and it will make a scan, that circular scan around the speaker's front. So it will scan a hemisphere around the speaker centered around the tweeter. And then it will make a secondary one a little bit outside of that. And using those two hemispheric scans, it's able to detect if the sound is moving out in this direction or is coming back from the other way based on its timing. So there will be diffraction off of these edges. So these act like little small speakers, just like this would have. And they come back at us, but clip-hole NFS is able to exclude that in software later on in its computational path because it noticed that the timing of those is way different than the timing of forward-firing sound source. Same with the rear reflections. The rear reflections will have to bounce off of walls and other things before they come forward, and the timing changes, and it's able to detect that and exclude it as well. So the bottom line is that measurements you're about to see reflect as if this speaker was mounted in a wall that's infinitely large. That means no effect from the back and no effect around edges of this thing. These edges do not exist in the measurements you're going to see. And that makes a huge difference when you measure a speaker like this. I've done it without this, and it's completely different and very unreliable. If you build a back box for it, just as well as broken, and because you get diffraction around the edges, the back box has to be sealed. And it's a mess. And I started that way, trying to economize without this software module, and it just doesn't work. So this is the way to do it. It's the system has got some limitations, maybe at some point I'll talk about. But in this case, it actually is pretty ideal and worked well with this. It is a lot of hassle measuring these speakers because every one of them, the sizes are not standardized. So, you have to build this baffle and mount the speaker in it, and then mount this on the stand. And, while I'm a woodworker, in wintertime, my woodworking job is remote. I don't want to go out there in the rain and try to cut this out. In this case, the owner was kind enough to go ahead and build this for me to the spec that I gave him. It has to be pretty large to allow for the dual scan, and he made this, and I added the registration points and the mounting system that I use in here. So bottom line, we're seeing anechoic measurements of the speaker, in-wall speaker, which in your real installation on a wall, it'll be very, very close to this. I must say I was very impressed with the frequencies. Actually, before I get there, let me cover this note. I founded a company called Madrona Digital about 14, 15 years ago after I left Microsoft. And Madrona Digital's business is to do custom integration for very high-end customers, both on commercial and residential, although it's mostly residential. And we don't do any retail, but we source a lot of products from many companies. And Madrona, Harman, parent company of Revel, is one. We use their amplification products, and we use their Revel speakers, a lot of in-wall, in-ceiling speakers. I don't know if we do this. But nothing comes to us from this kind of review. Madrona is an independent company. I founded that, and I run Audio Sounds Review. They have nothing to do with each other. Me giving a good or bad review to the speaker doesn't amount to anything for us because we don't sell speakers like this one-off. Somebody can come to us and buy them, but it's not a business that we're in. We're not a retail shop. We have no showroom. Our typical customer pays us more for security than they will ever do for audio system. Okay, so with that, anything subjective, you're welcome to read bias into it, but measurements, I can't cook the measurements. I set up the speaker like any other speaker, any other brand, and stuff comes out. So speaking of stuff coming out, this is our traditional spinorama or CEA 2034 measurement. Most important measurement I look at first is this black line, which is the on-axis response. And I put a reference line in red, and this is extremely good for any passive speaker, let alone one that's designed to go in-wall. In-wall speakers, as a rule, the business is all about just selling something that has an invisible grill and making money for the company and an installer. Getting quality to be good is not remotely important to them. Most customers buy these in-walls to just put them as, sound everywhere, and they don't care about fidelity. But in this case, Harman and Revel Group certainly has put in work to make sure that the tonality of this speaker is very neutral. Yes, there's little ups and downs in here. The clipable NFS has very high resolution in there, but it's extremely clean for, speakers. You could take the speaker, mount it in a wall, and be a hi-fi speaker, or in a box, and it'd be a hi-fi speaker ready to go. It has this gentle slope because it's not ported, even though the whole back is open. In this case, remember, it pretends as if the back doesn't exist. So you get this nice. It's a gently, rolling down. Whereas if you had a port, you get more extension, but then the drop is a lot faster. So these tend to be easier to cross to a subwoofer, which is a good thing because you don't want an in-wall speaker like this generating a lot of bass because you can rattle things off the wall. You can even crack the paint, and it's not easy to make it, drywall, at least in the US, to be very rigid. So, it's good that you don't get a ton of, sub bass, certainly. The other thing, which is unusual for Revel speakers, the sensitivity in here is quite high. This is around almost 90 dB efficient. And the reason for that is that infinite wall allows us to get reinforcement and not have to do what is called baffle compensation. So we can let the drivers do their best job they can by sort of projecting things forwards like a flashlight, concentrating sound energy coming forward. So very good in here, and that means even if you have modest amplification, you get good dynamics. Top use for these speakers is in home theater as a surrounds or fronts behind the screen, and there you want dynamics, and this thing will deliver. So you can take a standard AVR and drive it and get very good sound. Early reflections. This is designed for a standalone speaker that's away from a wall, so a little bit inaccurate, but more or less we can go by it, and shows how well behaved the speaker is. We can see that the response is very close to the on-axis, except it slopes down as it should, and it dips a little bit in here. The dipping is caused by these two strong reflections vertically that have much less energy around here, and they're ceiling and the floor. I hope if you're building a home theater that you have a carpet in it. It's a good place to put lots of absorption in there. And if you have carpet in there, this goes away, or mostly attenuates, and then this comes up. And notice that its frequency is above 2 kilohertz, just like I talked about the padding around my microphone. To absorb 2 kilohertz, you don't need to have a 6-inch absorber, just 2 or 3 inches will do a lot, and even 1 inch will do it. So make sure you have a thick carpet in your, or good thick padding that's breathable underneath your carpet for your home theater, if that's where you're using it. But even if you did nothing, it still would be quite good. This is a very, very modest dip in here. It's not consequential. And you can see its effect here, where, again, for a standalone speaker, we could predict this response if you put it in a box and put it in a room. We see that it has a nice slope down, which is what you want. Otherwise, it sounds too bright. We see that little bit of deviation I talked about in here, which you can try to EQ. Even though it's a directivity error, some research shows that you can boost this up if you wanted to 2 or 3 dB in here. I wouldn't mess with it unless you really had time to experiment. But it shows you how nice this is, that it competes with a standalone speaker in here. And so nothing unusual there. Our near field measurements, where I stick the microphone right at the drivers, doesn't show anything out of ordinary, and the reason for that is that we don't have a port, so nothing's interfering, and luckily nothing's rattling or anything, and response is pretty good. The crossover maybe could be a little bit lower order, but a higher order, but doesn't matter because the overall response is summing well. Now we get into very unusual graphs in here, and they're unusual because if you haven't looked at any in-wall speaker measurements, which I've done a few and I'm showing them, in that because you have walls around the driver, basically nothing can go behind, and all of that gets reflected forward. So the speaker has basically plus or minus, is fully just the sound that comes at you, and it's only at the highest frequencies where the tweeter grabs it and becomes more and more directional. And that tweeter takes over around 4 or 5 kilohertz and becomes directional. But when it gets directional, it's still very controlled. Doesn't do the classic thing where it keeps getting worse. And so design has gone into making sure that that stays controlled and flat. And so what that means is that tonality won't shift when you're left and right, which in a home theater is important because you have bunch of seats in there and you want to make sure the tonality doesn't shift. So overall, it's very nice. You can see the effect in here as a color-coded. This is the same as that one, just presented differently. I don't know why Klippel shows plus or minus 180 degrees in this graph. We would normally cover all the way behind the speaker horizontally. But in this case, it doesn't make sense because the walls will stop you from going behind the speaker. So this chart is not valid past these points. But if you look in here, you can see this plus or minus 50 degrees, this nice red channel in here, and there's no blue and green stuck in the middle of it that would cause holes in the response, off-axis response. So bottom line, this means it's good. Vertically, whenever you have 2 drivers that are the same, which in this case is the 2 woofers, and if you are at a different distance to one versus the other waveform will get delayed more than the other one, the primary one, and that delay causes 2 waveforms to then cancel at different frequencies, and that's the effect you're getting over here. Now, if you go a few degrees, nothing happens. So you want to stay plus or minus 20 degrees vertically. So as long as the timing difference is slight, you're okay. When you go very extreme, then all of a sudden things go bad on this thing. So You want to, in general, point this, put it at ear height if you can, or within 20 degrees. I don't know how you would tilt the woofers, which is the problematic area here. But for your fronts, for example, if you're using this behind an acoustically transparent screen, I would put them lower than higher, within 20 degrees of your ears, wherever you're sitting. So don't put them way up in the center of the screen, shooting sound above your head. Bring them down. If you have a screen, doesn't matter whether you have, wherever you have them. So make sure that shaft of sound is within that envelope and comes at you on this thing. But it's a classic problem we have with center speakers that are rotated. Then we get this problem in the horizontal axis, which is really bad. In this case, we have it in the vertical axis. And, you could eliminate it by taking out one of the drivers, but then you lose a lot of power handling. And I'll show you in a second how good the distortion characteristics are. Well, let's jump into that. And, at 86 dB SPL, this thing is not even crossing my 50 dB threshold for distortion. It's extremely clean. Even at 96 dB, it's still, motoring along with, very little distortion. There's critical bands where it's audible over here. Still very good. Bass distortion is well below 100%, whereas a lot of ported designs, the distortion goes even above 100%. So very good. And you can see it down here. Look at the distortion down here. It's extremely low, well below 0.5% over here, and almost negligible in certain frequencies. And at 96 dB, nothing crazy happens. It's just a little bit higher over here, which again, for a home theater speaker, super important to have good dynamics in here. And this thing delivers. And part of the reason this bass response is good is because you have the two woofers in there and the back is not constrained in a small box. So from that point of view, lost my thread. So yeah, so going to a one woofer, like a bookshelf speaker, you would have lost a lot of power handling. So if you have to stick a speaker, way the heck up by the ceiling, then think twice about using this speaker, because you're basically going to get your response is going to look like this. So at around 800 hertz to 1.5 or even 2 or 3 kilohertz, it's just going to have a hole in that response. Now, maybe for effects channels and things, it doesn't matter. I don't know but we talk about perfection and execution. Set them lower. I mean, they don't have to be as low as your ears, but, set them like this. You could try to tilt them a little bit, but then they look odd. And, if you mount them that way, I don't know. So it's a restriction of technology whenever you have two woofers and a tweeter in the middle. Impedance is typical of modern speakers in that it dips to 3.7 ohm. It's usually around this 200 hertz where that happens. And so you need to have an amplifier that can handle low impedance loads, so don't stick tube amps and stuff like that in there, which I don't think anybody would anyway. There are some resonances whenever there are kinks over here, like there's one here, there's one here. We call those resonances, and it's not good, but a lot of speakers have them, and who knows whether this is caused by how it was mounted to that MDF on this. And when you mount it to a real wall, you're going to have more of these things, because you're going to, that wall that you have is not made to be a speaker panel. So we can run a waterfall display and see the same thing. You can see that that resonance over here, and you see follow-up resonances. This display is almost useless, because if you look every time there is one of these things, there's also a peak in frequency response. So you could easily tell that you have a resonance at every one of these. And if you EQ that out, this also dies off with it. So that's why, even though I plot this CST waterfall, it really doesn't tell you anything new. And as I've said before, I can set the parameters where these things disappear. All I've got to do is move this floor up, and these things just vanish. And I can set the resolution where some of these kinks are there and they're not there. So anyway, if you want to be paying attention to stuff, is there. I certainly don't pay any attention to these things, but I got tired of telling people why I don't post impulse response and step responses. So here they are. Basically, this is the tweeter response is higher frequency, so it's much narrower, and this is a woofer response. It's lower frequency, so it takes more time to settle down. Okay, The speaker is still sitting on a stand as you saw it in the picture in the review. I haven't, yeah, I have no ability to mount it to a rear wall and listen to it. I'm not punching a hole in the wall. These things are not standardized anyway. It's just not practical for me to listen to it. So I'm not going to give you a review assessment of this thing. Based on measurements, I think it's going to be an extremely good speaker. Fortunately, the owner of this speaker performed a double-blind study with a bunch of people with this mounted in a wall, and this speaker finished at the top. So you have some confirmation from him. And also, Revel Group at Harman will not release a speaker without double-blind testing against his competitors. And so there's a lot of arrows pointing to this being a competent design. And by the way, it's only $495 retail. Revel speakers frequently get discounted by desperate dealers out there, so you may be able to get it even lower. So to get basically Revel performance, but they have to compete with all these other guys who sell these little, in-wall speakers really cheap, and so the pricing of them is very reasonable. It's not like high-end Revel speakers, but the performance is there. Okay, that's all I have for you. Hopefully you like all these very varied reviews. I'm trying to do a review on everything I post every day on Audio Science Review, so you get a broad exposure to different products. Okay, see you in a future video. Bye-bye.